Let's have a look at our design solution for turbopumps. Here, we will cover our mainline design codes, PUMPAL for the pump side of the design, as well as Axial for the turbine side of the design. We'll show the seamless integration into the 3D design world with our flagship product, AxCent. And we will cover all things pre- and post-processing in PB Post, linking the Concepts Design world with our partner Cadence CFD products. Starting in PUMPAL, a self-guided wizard will allow you to begin the 1D design of your machine, including your design specifications and some very preliminary geometric parameters. We include a cavitation model and a design towards minimizing MPSH. We allow for including diffusion models as well to guide us to your initial 1D result, which can be reviewed in a text form or many other different forms that we will get into. We also have integrated fluid libraries, including MIST and PRCE, to allow you to use real fluids with your design. Here, we can include multiple stages where we can design our pump with an inducer and a radial portion. And in Axial, we will have our templates, including drilled nozzles. If we want to look at performance maps, we can simply leverage our multi-point analysis tool, as well as a stall prediction to understand the limitations of our map. Once we have our full maps in 1D, we can move ourselves into the 3D design world and leverage some further design tools, such as including a sheared leading edge on an inducer, as well as using our embedded streamline curvature tool, MST, to have live feedback as we make our design changes. Here, we may look at something like blade loading, which commonly is an important design feature of our pumps. Here we can see an overloaded blade, and simply by changing our beta angle distribution, live real-time feedback as to the change in our blade loading to a more preferable location. We can also look at things like temperature rise through the machine or pressure rise through the machine, as we're showing here, to get that live feedback as we make our design changes. We allow for including a volute model, whether you're doing it following the parameters in the UI or simply dragging control points within the UI. On the turbine side, one of the main features that allow us to design the impulse style turbines is these drilled nozzles. Here you can use the table to get you started and then move on to a more detailed version of the nozzle design by using the control points within the UI to gain the geometry that you are looking for. We also allow control over the blading of the turbine itself, as you can see here. Once satisfied with the design, we'll move into the pre-processing using our PB Post tool. Here we can leverage the meshing control and add all of our loads and boundary conditions to be passed on for the fine turbo analysis. Here we can see one of the visualizations of our streamlines through the machine after a CFD has been completed. We can also visualize our results on the turbine side with the nozzles as well as the rotor. We can look at 3D results in conjunction with our 2D results to better visualize the performance of our machine. And lastly, we can look at a number of line plots across many different design parameters. All high-level results can be visualized in the run table, allowing you to compare between results or choose which design you'd like to run back through the mean line. Fine Agile for turbopumps is the solution for those looking to reach new heights with pump technology.